This is lesson 51, BHDL example 31. And you remember we saw in lesson 48 that we could use a plus sign to make an n-bit adder. And the question is, can we use a minus sign to make an n-bit subtractor? Well, as you might expect, we can, and it's very similar to the example we had for the adder. Remember, we have to use the use IEEE unsigned, and then we can have an A, n minus 1 down to 0, where we define the n to be generic, and we'll set it default to 8. B, n minus 1 down to 0 will be what we're subtracting, and then the difference y will be n minus 1 down to 0. So then in this process AB, all we have to say is y gets a minus b. So that's pretty simple, just like we had for an adder. And of course we can check it with a simulation. Here we take A to be 99 hex, and we make a little binary counter for different b's. So 99 minus 1, 1 is 8, 8. 99 minus 3, 3 is 6, 6. 99 minus 5, 5 is 4, 4, and so forth. If we subtract 99, we get 0. If you subtract BB, we get DE. You can check that. Of course, in this case, the borrow bit would be set because BB is larger than 99. Now, you might wonder how BHDL actually implements this minus sign. Remember, we saw that the plus sign was implemented by making an n-bit adder using full adders, just exactly the way we did. And if you go look in the IEEE unsigned VHD program, the arith one really, you'll find the function minus, which gets called when you execute a minus sign. And let's see how they do it. They define the variable BV, and then look what they do. They set the carry to 1, and then they set BV to not standard logic vector B. They're converting B. Now, this is what? This is a 1's complement plus 1, which is a 2's complement. So they're taking the 2's complement of B, and then they're building exactly the same adder that we had for the plus sign, where they go through for I equals 0 to the number of bits, and the sum is A exclusive OR B exclusive OR with a carry, and then the carry. So this is exactly the same as we had for the plus sign. Well, this is just what we did in the last example when we made our adder subtractor, you remember. They're basically setting E to 1. Remember, we set E to 1. That sets this carried bit to 1 coming in. And then we had the exclusive OR gate as a controlled inverter. That just knots it for the subtraction. And then we showed that a full adder could behave as a full subtractor by just taking the 2's complement of the input and adding it, which is what they do here. So that's how they implement the minus sign in BHDL.